At the start of World War II, the Douglas Aircraft Company was the main supplier of dive bombers and torpedo planes for United States carrier aviation. Back then, the mainstays of the flight decks were the 2-seat SBD Dauntless dive bomber and the 3-seat TBD Devastator torpedo bomber. The Dauntless really made a name for itself in combat. In fact, historians later called it one of the best dive bombers of the entire war. However, both of these aircraft were built to meet requirements dating back to 1934. So by the middle of the conflict, they were hopelessly outdated and were being replaced by newer designs: the Curtiss SB-2C Helldiver and the Grumman TBF Avenger. Because of this, Douglas temporarily lost its spot as the top manufacturer of carrier strike aircraft. In the mid-40s, Douglas decided to reclaim its leadership. To do this, their engineers created two entirely new aircraft. These were the XSB-2D Destroyer and the XTB-2D Skypirate. The United States Navy ordered the first experimental prototypes of these aircraft in 1943. The Destroyer was conceived as a direct successor to the Dauntless. It was powered by a massive Wright R3350 engine pumping out 2,300 horsepower. This dive bomber featured a pretty unusual design for carrier aviation at the time. It had tricycle landing gear and an inverted gull wing. The Americans had only used this wing configuration on a carrier aircraft once before. This configuration not only made the aircraft much more stable in flight, but also allowed for shorter main landing gear struts. On top of that, the aircraft packed some serious defensive firepower. It had two remote-controlled turrets located in the dorsal and ventral positions of the fuselage. Meanwhile, the XTB-2D torpedo bomber was built specifically to replace the Grumman Avenger. The Skypirate shared the same tricycle landing gear setup as the Destroyer, but it was much larger and featured a traditional straight-wing design. Its standout feature was the power plant. The aircraft was fitted with the most powerful piston engine of the era. This was the 28-cylinder Pratt & Whitney R4360. This giant engine drove dual contra-rotating propellers. The aircraft's defense was also impressive. 50 caliber machine guns were mounted in the dorsal turret and a single cannon in the ventral one. However, the shifting tide of the Pacific War altered tactical needs. United States naval aviation had achieved near absolute air superiority. Because of this, the need for heavy, multi-crew aircraft with defensive turrets simply vanished. Now, the Navy needed light, versatile, single-seat strike aircraft. They had to be capable of attacking enemy ships with bombs in a steep dive, as well as executing low-level torpedo runs. Navy Command created a brand new designation just for these aircraft. This designation was BT. A new competition was immediately announced among the top carrier aircraft manufacturers. Right around this time, the Navy pulled the funding for Douglas's previous projects. But as luck would have it, the chief engineer of the company's advanced design department, Edward Heinemann, was in Washington with his team. Gathering in a hotel room, the engineers sketched out the basic design of a completely new aircraft over a single night. And by the very next morning, Edward Heinemann walked into the Navy's offices with completed blueprints for a new combined dive and torpedo bomber. The Navy brass loved the idea so much that they immediately greenlit the project and put the company back into the competition. The new aircraft was designated XBT-2D1. Besides Douglas, other major aviation giants were fighting for the lucrative contract. These included Curtiss, Martin, Kaiser Fleetwings, and Boeing. The Curtiss company showcased their XBT-2C aircraft. It was a heavily modernized version of their Helldiver dive bomber. In March 1945, they received an order to build 10 prototypes. They decided to equip these planes with Wright R3350 Cyclone 18 engines rated at 2,500 horsepower. These replaced the originally planned Pratt & Whitney R4360 Wasp major engines. Those produced 3,000 horsepower. The armament on this bomber consisted of two 20mm cannons and 2,000 pounds of bombs, or a single torpedo. In practice, however, this aircraft fell noticeably short of its competitors in key performance metrics. Because of this, the project was eventually canceled. The factory only managed to produce 9 prototypes. For the legendary Curtiss Company, these became the last aircraft they ever designed for the U.S. Navy. Martin's XBTM-1 earned the fearsome name Mauler. It looked a bit like the designs of the famous aircraft engineer Ed Heinemann. The Navy viewed this plane as the primary and most serious competitor to the Douglas design. This prototype made its maiden flight late in the summer on August 26, 1944. The aircraft was powered by a Pratt & Whitney R4360 Wasp major engine. It cranked out an impressive 3,000 horsepower. For armament, the attack aircraft boasted 4 20mm cannons. It featured 15 external hardpoints under its wings, where bombs and rockets could easily be mounted. Flight testing of the first prototype went very well. On January 15, 1945, the U.S. Navy placed a substantial order for 750 of these aircraft. The first production Mauler was given the designation AM-1. It successfully took to the skies on December 16, 1946. Throughout the following year, several of these planes underwent carrier trials. In the spring of 1948, they entered fleet service with their first fully operational combat squadron. Their triumph was short-lived, though. In October 1949, the decision was made to completely halt production. By that point, they had only managed to build 151 aircraft. And by the very next year, all AM-1s were completely withdrawn from frontline service. Interestingly, besides the standard attack variants, engineers rolled out a few specialized aircraft. There were anywhere from 6 to 17 units, depending on the source. They were designated AM-1Q, and they were purpose-built for electronic warfare. Meanwhile, Kaiser Fleet Wings went down a totally different path. They created the relatively small, affordable, and extremely easy-to-produce XBTK-1. They equipped it with a Pratt & Whitney R2800 double Wasp engine. However, the gamble on economy did not pay off. Its payload was too small, and its flight performance was frankly disappointing. Because of this, the Navy showed absolutely no interest in the project. They only agreed to fund the construction of 5 prototypes. Aviation giant Boeing also pitched their own design. Their XF-8B-1 project was built on the foundation of their XF-8B heavy fighter concept. The main features of this new aircraft were a spacious internal bomb bay capable of holding over 1,600 pounds of ordnance and a unique power plant. It featured a pair of 3-bladed contra-rotating propellers. These propelled the plane to an impressive top speed of 432 miles per hour. But this was another failure. The design of the XF-8B-1 turned out to be completely unsuited for the harsh realities of carrier operations. Therefore, the Navy leadership ultimately canceled the program. The torpedo bomber designed by Edward Heinemann, the Douglas XBT-2D1, along with its rival, the Mauler, ultimately won the military competition. Initially, the U.S. Navy placed a massive order. They planned a production run of 623 of these aircraft, which were to be designated the BTD-1. However, in late 1944, this order was abruptly canceled. Despite this setback, the interest of the Navy in the Heinemann bomber remained consistently high. Shortly after, in the official documents of the Bureau of Aeronautics, the aircraft reverted to its original XBT-2D1 designation. 15 prototypes were ordered for rigorous flight testing. This number was later increased to 25 aircraft. This decision gave Douglas precious extra time to work out the kinks in what was still an unproven design. Hoping to get the aircraft into production before the end of World War II, management assembled an elite design team led by Edward Heinemann. They focused the team exclusively on the XBT-2D1. The team included top-tier talent, notably Chief Engineer Leo Devlin and lead aerodynamicist Gene Root. Working at a frantic pace, they managed to design what was essentially an entirely new aircraft in record time. They gave it the working name Dauntless II. Compared to its competitors, it stood out thanks to the exceptional structural weight efficiency of the airframe. Even though the official Navy specifications set a strict maximum takeoff weight of 13,230 pounds, the design team managed to bring the bomber in 595 pounds under that limit. To ensure a substantial combat radius, they installed a massive 351-gallon internal fuel tank positioned directly on the aircraft's center of gravity. Thanks to this clever engineering choice, fuel burn during a mission did not shift the center of gravity at all. For extended missions, a standard Mark 12 drop tank could easily be mounted under the fuselage. This held an additional 150 gallons of fuel. External ordnance was carried on 3 heavy-duty pylons, 1 on the aircraft centerline and 2 near the wing roots. Interestingly, these wing pylons served a highly practical secondary purpose, acting as makeshift skids to protect the airframe during an emergency wheels-up belly landing. Interestingly, the Dauntless II was designed without any defensive armament. However, the pilot was provided with an exceptionally comfortable working environment. He sat in a spacious cockpit featuring a clear bubble canopy that offered fantastic all-around visibility. To ensure the attack aircraft delivered truly outstanding performance, the plan was to mount the brand new R-3350 Cyclone 18 radial engine up front. This engine was capable of producing a massive 2,500 horsepower, but production realities set in. The airframe was completed much faster than its intended power plant. Development of the new engine was severely delayed due to endless testing required to resolve a host of technical issues. As a result, the engineers had to compromise. They installed an older, less powerful, but time-tested 2,300 horsepower variant of the R-3350 into the finished Dauntless II prototypes. During development, the engineering team paid close attention to the cockpit layout. The results exceeded all expectations, with pilots themselves calling it the most advanced and comfortable cockpit of its era. To optimize the aerodynamics, the air intake ducts underwent rigorous wind tunnel testing. This took place at the California Institute of Technology starting in late July 1944. However, the final design of these critical components was not officially completed until early March 1945. The experimental XBT-2D-1 bomber was scheduled to make its first flight on June 1, 1945. But time was tight and they needed to move fast. To avoid losing precious days, the design team came up with a clever workaround. Instead of waiting for the aircraft's custom-designed main landing gear struts and wheels, they borrowed existing components from the F-4U-1 Corsair fighter. This brilliantly simple solution got the bomber ready for testing a full 2 weeks ahead of schedule. On May 18, 1945, Douglas test pilot Laverne Brown took the aircraft up for its maiden flight from the runway at Mines Field. Factory testing lasted for 5 intense weeks, with the aircraft completing around 40 test flights. The engineers thoroughly verified all the performance estimates. Company management was highly satisfied with the new bomber's performance. After that, Laverne Brown ferried the aircraft to the Navy's test center at Patuxent River, Maryland. He handed it off to military pilots for further evaluation. The naval aviators were unanimous in their verdict. They called the XBT-2D-1 the best carrier-based bomber that had ever come through their facility. The aircraft perfectly met all the Navy's strict requirements. Its standout features were its exceptional handling characteristics and ease of maintenance. Of course, a few issues came up during testing, but they were typical teething problems for a new airframe. The pilots asked for an oxygen system in the cockpit for high-altitude flights. The ground crews pointed out that lighting needed to be improved in both the cockpit and the tail equipment bay. Douglas responded instantly and took care of all these requests. Thanks to this quick turnaround, on May 5, 1945, Navy brass signed an official letter of intent to buy an initial order of 548 BT-2D bombers. With the abrupt end of World War II, mass production of combat aircraft came to a grinding halt. This happened almost the day after the fighting stopped. The scale of the canceled military contracts was staggering, totaling roughly $8 billion. Over 30,000 aircraft in various stages of assembly were simply scrapped. This wave of cuts also affected the Douglas order for the BT-2D. First, the order was slashed to 377. Later, it was cut down to just 277 aircraft. Yet even this modest contract, at least by wartime standards, turned out to be a real lifesaver for the manufacturer. While other aviation giants were taking massive losses and going bankrupt, Douglas managed to stay afloat. Meanwhile, work on refining the design kept going. The second XBT-2D-1 prototype made its first flight on May 8, 1945. During its in-depth testing, engineers uncovered a few hidden defects in the propulsion system. The main culprit turned out to be the propeller, which was generating excessive vibration. The high-frequency vibrations were so intense that they were causing fatigue cracks even on the heavy-duty exhaust stacks. To fix this problem, the aircraft had to go through specific vibration testing. After that, it was sent over to NACA specialists for extensive runs in their full-scale wind tunnel. It wasn't until early August that this second prototype was sent back to the factory for final modifications. Despite all the hurdles, by the end of 1945, the company had successfully assembled all 25 pre-production aircraft. The first 4 aircraft were temporarily equipped with R3350-8 engines. The rest were fitted with the full production R3350-24W engines called for in the original design specifications. The weapons payload was particularly impressive. Besides the 3 main pylons for external ordnance, they mounted another 12 smaller hardpoints under the wings. Each of these could handle loads of up to 110 pounds, and the standard armament consisted of 2 heavy 20mm cannons. To edge out their main competitor, the Martin Mer, Douglas engineers decided to bet on versatility. They pitched their BT-2D as a highly versatile multi-role aircraft, capable of taking on practically any mission required of carrier-based strike and utility roles. To prove it, the company took 6 experimental airframes and converted them into several specialized variants. One was turned into the XBT-2D1P photo reconnaissance variant. Another became the XBT-2D1Q for electronic countermeasures, and a third became the XBT-2D1W airborne early warning platform. 2 more airframes received modern equipment and radars in underwing pods. They underwent testing as XBT-2D1N night attack variants. Finally, the 6th aircraft was transformed into the prototype for the next iteration, the XBT-2D2. This was positioned as a dedicated carrier-based attack aircraft. In February 1946, the BT-2D, previously known as the Dauntless II, was officially named the Skyraider. By April of that year, the United States Navy made a major decision. The bomber torpedo class, designated by the BT prefix, was dropped entirely. In its place came the new A classification, standing for attack. The designation of the aircraft followed suit. From then on, the Skyraider became simply known as the AD. In late spring of that same year, several AD test variants began carrier qualification trials. However, the results were disappointing. The airframes simply were not strong enough. They could barely withstand the punishing hard landings inherent to carrier operations. The main issues were weak landing gear and structural vulnerability at the wing and horizontal stabilizer routes. The engineering team was forced to rapidly redesign the airframe and reinforce those high-stress areas. As a result of these modifications, the production AD1 packed on some extra weight. It weighed in 516 pounds heavier than the first XBT-2D1 prototype. The first production AD1 took to the skies on November 5, 1946. By April of the following year, the aircraft began entering fleet service with attack squadrons VA-3B and VA-4B. They operated off the carriers USS Sicily and USS Franklin D. Roosevelt. Full-scale production ran through mid-1948. As for armament, aside from the usual bombs and torpedoes, the arsenal of the AD-1 was expanded. It now included the powerful 5-inch high-velocity aircraft rocket, widely known as the HVAR or the Holy Moses. The top speed of the attack aircraft reached 310 knots. Its combat range was an impressive 1,350 nautical miles. In total, 241 production AD-1s rolled off the assembly line during this run. While upgrading the existing fleet, Douglas engineers were looking to the future and exploring advanced concepts. The issue was that externally mounting unguided rockets created a serious problem. It significantly increased parasitic drag and induced severe wing flutter during flight. To solve this, the design team decided to heavily modify one of the test airframes. Instead of the standard wing-mounted cannons, they installed 2 special tubular rocket packs. These were capable of carrying an impressive 38 Aero X-10A rockets, which could all be ripple-fired in just 6.5 seconds. To keep the hot rocket motor exhaust from damaging the airframe, the gases were vented through specially designed ducts angled aft and downward. After launch, the rockets were spin-stabilized. Each launcher weighed 161 pounds empty. Meanwhile, a fully loaded pod tipped the scales at 838 pounds. This heavily modified aircraft successfully completed a series of ground firing tests at the Naval Ordnance Test Station at Inyokern, California. However, despite the clever engineering, the military just was not thrilled about completely losing the cannons of the aircraft. As a result, by the summer of 1950, all work on this experimental program was permanently canceled. Interestingly enough, the last 25 airframes from the initial production run were built as two-seaters. They were specially modified to serve as electronic warfare platforms. All the bulky electronic equipment was housed deep inside the fuselage. The suite included a search receiver, a pulse analyzer, and a panoramic display. To get to their station, the ECM operator used a separate, small door on the left side of the aircraft. Additionally, the aircraft carried a specialized underwing pod. This pod housed a radar unit and a chaff dispenser designed to jam enemy radar systems. The evolution of the attack aircraft did not stop there. In the spring of 1948, an upgraded variant of the Skyraider began entering fleet service. Designated the AD2, this new version boasted a noticeably stronger wing structure and a more powerful R3350-26B engine. This power plant cranked out an impressive 2,700 horsepower. It featured redesigned exhaust stacks along with a more reliable low-voltage ignition system. And best of all, it burned noticeably less fuel. On top of that, engineers expanded the internal fuel tank capacity by 15 gallons, giving the aircraft some extra range. To make those long missions a bit more bearable for the pilot, the cockpit was also fitted with a new, much more comfortable headrest. Engineers decided to use one of the production aircraft from the AD2 run to test out an entirely new engine cooling system. After those tests wrapped up, the airframe was fitted with a special underbelly radome. This was the exact same type used on the experimental AD1W. Eventually, designers took the standard AD2 and developed a two-seat version specifically tailored for electronic warfare, designated the AD2Q. When it came to the internal layout and the suite of specialized equipment, it was practically identical to its predecessor, the AD1Q. In total, 21 of these aircraft rolled off the assembly line. Another unique aircraft from this series, designated the AD2QU, was specially modified for a completely different mission. This role involved towing aerial targets. For this purpose, a massive pod was securely mounted to the centerline pylon under the fuselage. Inside was a tow cable, a heavy-duty winch, and the actual Mark 22 target sleeve. Ironically, the development of the third major Skyraider variant was driven by a critical design flaw. This issue occurred during the early development phases of the aircraft. During operational flying with the first two versions, pilots ran into a serious problem. At high speeds, the aircraft suffered from severe yaw instability. This caused the aircraft to violently yaw back and forth in the air. This tendency became especially dangerous during a steep dive, and it severely degraded bombing accuracy. The Douglas Aircraft Company tried to solve this problem, however, they just could not pinpoint the root cause and resolve the issue on their own. So they transferred one of the AD2s to the experts at the National Advisory Committee for Aeronautics. There, the aircraft was placed inside a massive wind tunnel for thorough testing. Naturally, they did not run the engine during these tests, however, they wanted to get the most accurate picture possible of how the airflow moved around the fuselage. To do this, they simultaneously tested a scaled-down model of the aircraft equipped with a spinning propeller. They only managed to solve the issue after a series of risky test flights where they locked the rudder completely in place. The engineering team had actually suspected the rudder right from the start. It turned out its design was just flat-out flawed. To make matters worse, the trim tab had been installed at the wrong angle. Only after engineers made the necessary design changes did the dangerous high-speed flutter finally disappear. The next production variant, the AD3 Skyraider, started rolling out with a more powerful R3350-26W engine. The designers also decided to ditch the complex retractable tailwheel. The tailwheel strut was now fixed in place. This turned out to be a highly practical solution. Deck crews could easily hook up a small tow bar to it. This made it incredibly fast and simple to maneuver the heavy aircraft around the cramped deck of an aircraft carrier. The cockpit also saw some significant changes. It specifically featured a much more ergonomic instrument panel. Engineers updated the shape of the canopy. They tweaked the propeller design and improved the engine cooling system. With all these upgrades, the maximum takeoff weight of the AD3 pushed well past 18,500 pounds. Ultimately, Douglas built 124 of these aircraft. The next batch of 23 aircraft received the designation AD3Q. These were specialized two-seat variants designed for electronic warfare. If needed, they could also be used to tow aerial targets during training exercises. Understanding the Navy's need for round-clock operations, Douglas developed another unique version. This was the AD3N. It was built specifically for flying devastating night strikes against enemy ground targets. It looked very similar to the AD3Q on the outside. Between September 1949 and May 1950, the Navy took delivery of 15 of these night attackers. The crew was expanded to 3. To spot targets in the dark, a massive pod housing a state-of-the-art radar was slung under the left wing. The real breakthrough came with the next production variant, the AD4 Skyraider. It was powered by the beefed-up R3350-26WA engine. This engine cranked out an impressive 2,700 horsepower. It was designed with the demands of the Korean War in mind. The engineering team incorporated all the extensive operational experience gained from previous variants. To protect the pilot from enemy small arms fire during low-level strafing runs, the front windshield was fitted with heavy-duty armored glass. Since sorties often dragged on for hours, a P1 autopilot was installed to ease the pilot's workload. The instrument layout was optimized once again. To cut down on deck accidents during hard carrier landings, engineers significantly reinforced the tailhook. Firepower was ramped up as well. 4 cannons were now mounted directly in the wings. Naturally, with the extra armor and equipment, the aircraft's overall takeoff weight noticeably increased. Because of this, its operational range took a slight hit, dropping to 1,240 miles. In actual combat, though, this drawback was completely offset by the Skyraider's incredible effectiveness and sheer survivability. By the time the war ended, Douglas had rolled out over 300 of these Korean War-era AD4s. The total production run for this highly successful variant topped out at 398 units. The next major batch to roll off the assembly line was the AD4N. This was a 3-seat night attack aircraft armed with a pair of cannons. It boasted a high-intensity searchlight and a special underwing pod housing a radar system. Interestingly enough, most of these airframes were delivered to the Navy under a different designation, the AD4S. This reclassified them as anti-submarine warfare planes, but the harsh realities of combat quickly forced a change. In the field, they were often converted back into classic attack aircraft. All the unnecessary ASW gear was stripped out, and the previously removed cannons were reinstalled in the wings. These field modifications earned their own designation, the AD4NA. In September 1962, the attack aircraft still in service were redesignated as the A-1D under the new tri-service system. But years earlier, the Douglas Aircraft Company put 36 airframes through a specialized upgrade. This was to make sure these planes could operate effectively in the brutal, unforgiving Korean winter. They created a dedicated cold weather variant, the AD4NL. This version was fitted with a wing de-icing system. Its firepower was also bumped up to 4 cannons. In 1959, with the Algerian War raging, the United States transferred a massive batch of Skyraiders to the French Air Force. This was done to help counter the uprising. This included 93 attack aircraft in both the AD4NA and AD4N variants. By February 1960, these formidable warbirds had joined the ranks of the 2nd Squadron. Later, they joined the 1st and 3rd Squadrons of the 20th Wing of the French Air Force. Before deployment to the Algerian theater, the AD4N aircraft were brought up to the AD4NA standard. On top of that, all the airframes were modified. They could now carry and deploy French bombs and unguided rockets. In the skies over Algeria, these attack planes proved to be incredibly effective. However, it was not without losses. Rebel forces still managed to shoot down a handful of aircraft. When Algeria finally won its independence, the French command reorganized its units. The 1st and 3rd Squadrons were transferred to the 21st Wing. Meanwhile, the 2nd was officially disbanded. But the combat record for these aircraft did not end there. In 1963, the 1st Squadron saw heavy action in French Somaliland. A few more airplanes were deployed to Chad, which had just gained its independence from France. There, they flew close air support and policing missions. This helped to suppress numerous armed uprisings in the central regions of the country. The era of the French Skyraider finally came to a close in the 1970s. At that time, the venerable aircraft were permanently retired from service. Let us jump back a bit to the late 1940s. Back then, at the request of the Navy, Douglas developed a highly unique variant of the Skyraider. This variant received the designation AD4B. Its primary mission was carrying and delivering nuclear weapons. Specifically, this meant the Mark 7 or Mark 8 tactical nukes. Full-scale production of the Mark 7 bomb ramped up in 1952. This bomb boasted a yield of 1 kiloton. This was a massive technological breakthrough. For the first time in history, the size and weight of a nuclear payload allowed it to be carried by a standard, relatively small carrier-based aircraft. A typical loadout for this atomic strike aircraft consisted of a single nuclear bomb. It also included 2 massive 300-gallon drop tanks. With the Mark 7 bomb, the combat radius of the aircraft was around 900 nautical miles. With the newer, more advanced Mark 8, that extended out to almost 1,440 nautical miles. To deliver this nuclear payload safely, attack pilots relied on a technique known as toss bombing. American pilots themselves jokingly called this maneuver the over-the-shoulder toss. Here is how it worked. The pilot would enter a steep, high-speed dive toward the target. Then they would pull back hard on the stick to initiate a half loop. They released the nuclear bomb just as the aircraft pitched upward. While the deadly weapon followed a high ballistic arc toward the ground, the pilot rolled upright and bolted in the exact opposite direction at full throttle. This evasive maneuver bought the pilot a few precious seconds. It allowed them to put as much distance as possible between themselves and the nuclear blast. Of course, even a clever tactic like this was hardly a guarantee of survival. This is underscored by the fact that live nuclear weapons were never actually loaded onto these aircraft, let alone dropped in combat. In all likelihood, this atomic attack plane was really just a clever political tool. The Navy simply used it as leverage in their fight against the Air Force for a bigger slice of the defense budget. Still, the engineers took the assignment incredibly seriously. They heavily reinforced the airframe so it could withstand a massive shockwave. In total, there were 298 of these aircraft. Exactly 165 of them were purpose-built. The rest were converted from standard AD4 attack aircraft. Then, in late May 1953, something truly historic happened. A single AD4B set an all-time payload record for single-engine piston aircraft. It successfully got airborne, carrying an unbelievable payload for the time. It was over 14,950 pounds. Toward the end of their service life, 12 retired but still rugged Skyraiders were sold to Sweden. Before transferring the aircraft to their new owners, the United States Navy carefully stripped out all the classified radar gear and the tailhooks. The Swedish military repurposed these attack planes for a non-combat role. Right up until the mid-70s, they used them as target tugs for aerial training. Eventually, 2 of the airframes were lost in crashes during these flights. But for the rest of the fleet, it was a quiet and respectable end to their service.